Peter, is there really a formula that tells us how many primes there are?
Sort of. It's called the prime number theorem. It doesn't give you exact primes, but it nails their overall distribution.
Distribution? Like how spread out they are?
Exactly. Let's say pi of x is the number of primes less than or equal to x. The theorem says that pi of x is asymptotically equal to x over ln x. For example, around 1,000,000, the probability a number is prime is about 1 inch 13.8. Not bad for such a chaotic-looking sequence.
Okay, but how do you prove something like that?
That's where it gets legendary. Hadamard and De La Vallée-Poussin cracked it in 1896 using complex analysis, specifically the Riemann zeta function. They showed it has no zeros on the line, real part of s equals 1, and that fact unlocks the asymptotic formula.
And didn't Erdős and Selberg find a proof without complex analysis?
Yep, in 1949. A purely elementary proof, though still very tricky. 2 different roads to the same deep truth.
So we don't know exactly where primes are, but we know how often they appear.
Exactly. The prime number theorem tells us primes are infinite but predictable in density, and if the Riemann hypothesis is true, we'd know even sharper error bounds.
So this sits right between certainty and mystery.
Perfect summary, Stewie. If that blew your mind, follow for more math that turns chaos into patterns.